Habari Zenu, future engineers of Kenya. My name is Titus Kiplimo, and it is my great pleasure to welcome you to our class here at Moiben Technical and Vocational College. I see many bright faces ready to learn, and that makes me very happy. We are going to be spending our time together, getting our hands dirty and our minds sharp as we explore the world of automotive engineering. This is a journey, my friends, a very exciting one. You are the people who will keep our country moving, who will fix the matatus, the lorries, and the personal cars that are the lifeblood of our economy. So let's start this journey with energy and a big smile, because what we learn in this workshop will build your future and the future of transport in our beloved Kenya. Now let me ask you something. What is the most important part of a car? Some of you might say the engine because it gives power. Others might say the wheels because they make it move. But I will tell you, my friends, the most important part is the one that stops the car. Yes, the braking system. In Africa, our roads are full of surprises. You can be driving smoothly on the Nakuru-Eldoret highway, and suddenly, a herd of goats decides to have a meeting in the middle of the road. Or a boda rider with a passenger carrying a full-grown sofa appears from nowhere. It is in these moments that you will thank your brakes. They are not just parts, they are your guardian angels on the tarmac. Understanding brakes is a matter of life and death, and that is not an exaggeration. A car that can go fast is exciting, but a car that cannot stop is a metal coffin on wheels. The safety of your driver, your passengers, your cargo, and even the pedestrians on the side of the road depends entirely on how well that braking system is maintained. As a professional automotive engineer, you are the doctor for these systems. You are the one who will ensure that when a driver presses that pedal, the car responds immediately and safely. This responsibility is huge, and it starts here, in this classroom, by understanding every single nut, bolt, and fluid that makes up the system. So what is the main job of the brakes? It's not just about stopping. The braking system has several key functions that work together to give the driver complete control over the vehicle's speed. Its primary function is to slow the vehicle down at a controlled rate. Secondly, it must be able to bring the vehicle to a complete stop, and do so in the shortest possible distance in an emergency. Finally, it must be able to hold the vehicle stationary, especially on a hill, which is the job of the handbrake or parking brake. Mastering how to service these functions is what separates a casual mechanic from a true automotive professional. Let's get ready to become professionals. So how does this magic happen? How does pressing a small pedal with your foot stop a 2-ton machine traveling at 80 kilometers per hour? It is not magic, my friends, it is science, specifically the science of hydraulics and friction. The entire process starts the moment the driver's foot touches the brake pedal. This simple action is the command that sets off a chain reaction throughout the braking system. Think of it like sending a message. You press the pedal and you are telling the wheels, hey, it is time to slow down, and I mean now. The system is designed to take the small amount of force from your foot and multiply it into a massive force capable of stopping the car. This multiplication of force is the job of the hydraulic system. Your car's brakes are filled with a special liquid called brake fluid. When you press the brake pedal, you are pushing a piston inside a component called the master cylinder. Because you cannot compress a liquid, this action sends the brake fluid under high pressure, shooting through a network of small pipes and hoses that lead to each wheel. This is based on Pascal's principle, a fancy name which simply means that pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid. So, the small push from your foot becomes a powerful push at each of the 4 wheels simultaneously. At each wheel, this hydraulic pressure is put to work to create friction. Friction is the force that resists motion when 2 surfaces rub against each other, and it is the hero of our story. The incoming high-pressure brake fluid forces a set of brake pads to clamp down on a spinning metal disc, or it pushes brake shoes outward against the inside of a spinning drum. This rubbing action creates immense friction, which works against the rotation of the wheel. The energy of the moving car, which is kinetic energy, is converted into heat energy by this friction. That is why brakes can get very, very hot after heavy use, sometimes even glowing red. So to put it all together in a simple way, your foot pushes the pedal. This push is magnified by the brake booster and used by the master cylinder to create high pressure in the brake fluid. This high-pressure fluid travels through the brake lines to the wheels. At the wheels, this pressure is used to force brake pads against a disc or brake shoes against a drum. This creates friction, which converts the car's movement energy into heat, slowing the wheels down and bringing the vehicle to a safe and controlled stop. It is a beautiful and effective system, and understanding this flow of force is the first step to mastering it. As disc brakes, drum brakes are cheaper to manufacture and are also very effective for the parking brake mechanism. Even the best systems can develop problems, and as engineers, your job is to be the doctor who diagnoses the sickness. One of the most common complaints you will hear is a squealing or grinding noise when they brake. A high-pitched squeal is often caused by a small metal tab on the brake pad called a wear indicator. It's a built-in alarm telling you the brake pads are worn out and need to be replaced. If the driver ignores this sound, it will turn into a loud metallic grinding noise. This is a very bad sign. It means the brake pads are completely gone, and now the metal backing plate is grinding against the metal rotor, causing serious damage. Another common problem is a spongy or mushy feeling in the brake pedal. When the driver presses the pedal, it feels soft and goes down much further than usual before the brakes start to work. This is almost always a sign of air in the hydraulic system. Remember, brake fluid cannot be compressed, but air can. So, when there is air in the brake lines, your foot pressure is wasted on squeezing the air bubbles instead of applying the brakes. This is a very dangerous situation that requires immediate attention. The solution is to bleed the brakes, a process we will discuss soon, to remove the trapped air. What if the car pulls to one side, to the left or right, when the driver brakes? This is another classic symptom that you will encounter. Imagine you are driving straight, you press the brakes, and the car suddenly wants to change lanes by itself. This usually indicates that the brakes on one side are working harder than on the other. The cause could be a stuck caliper on one wheel, which is not clamping properly, or a clogged brake line that is not delivering enough pressure to that wheel. It could also be as simple as contaminated brake pads on one side, perhaps with oil or grease, which reduces their friction. Finally, you might get a complaint about a vibrating or pulsating brake pedal, especially during hard braking from a high speed. The driver will feel the pedal shaking under their foot. This is a strong indication that the brake rotors, the discs, are warped. This means they are no longer perfectly flat. The cause is usually excessive heat from heavy braking, which can cause the metal of the rotor to distort. As the warped rotor spins, the brake pads are pushed back and forth as they clamp onto the uneven surface, and this pulsation travels all the way back to the brake pedal. The only solution for this is to either resurface the rotors on a special lathe or replace them completely. We have mentioned the problem of a spongy pedal caused by air in the brake lines. The cure for this sickness is a procedure called brake bleeding. This is a fundamental skill for any automotive technician. The goal of bleeding the brakes is to systematically force out the old contaminated fluid and any trapped air bubbles, replacing them with fresh, clean brake fluid. Air can get into the system when it is opened for repairs, like when replacing a master cylinder or a brake line, or sometimes through tiny invisible leaks over time. Since air is compressible, it severely reduces the hydraulic pressure and makes the brakes unreliable and dangerous. The process of bleeding brakes is a two-person job. One person, the assistant, sits in the driver's seat to operate the brake pedal. The other person, the technician, works at each wheel. At each wheel's caliper or wheel cylinder, there is a special valve called a bleeder screw. The technician attaches a small clear hose to the bleeder screw and puts the other end into a jar with some clean brake fluid in it. The process is a coordinated dance. The assistant slowly pumps the brake pedal a few times to build pressure and then holds the pedal down firmly. While the pedal is held down, the technician briefly opens the bleeder screw. When the bleeder screw is opened, the pressure in the system forces the fluid and any trapped air out through the hose. You will see the air bubbles coming out into the jar. The technician then quickly closes the screw before the assistant releases the brake pedal. This is very important. If you release the pedal while the screw is open, it will suck air right back into the system. This process is repeated several times at each wheel, starting with the one furthest from the master cylinder and working closer until no more air bubbles are seen coming out of the hose, only clean, clear brake fluid. This procedure ensures that the hydraulic system is a solid, air-free column of fluid from the master cylinder all the way to the wheels. The result is a firm brake pedal that responds instantly, giving the driver confidence and control. Regular brake fluid flushes, which is essentially bleeding the entire system to replace old fluid, are also a key part of preventative maintenance. Brake fluid absorbs moisture from the air over time, and this water can cause corrosion inside the system and lower the fluid's boiling point, making the brakes less effective under heavy use. Now that you understand these principles, let's put our minds to work with some assignments. Discussion assignments, and please work in pairs. First, Scenario 1. A customer comes to you complaining that their car makes a loud grinding noise every time they brake, and the car takes longer to stop. What do you think the problem is? What parts would you inspect first, and what would you tell the customer about the dangers of continuing to drive the car? Next, the African Roads Challenge. Discuss and list 5 unique challenges on Kenyan roads. For example, potholes, livestock, overloaded vehicles, and explain how each challenge puts extra stress on a vehicle's braking system. Then, disc versus drum. Create a simple table comparing disc brakes and drum brakes. List at least 3 advantages and 3 disadvantages for each type of brake. Which system would you prefer to have on the front wheels of your car and why? Now, the brake fluid mystery. Your partner tells you that since brake fluid is in a sealed system, it never needs to be changed. Using what you learned today, explain to your partner why this is wrong and dangerous. Describe what happens to brake fluid over time and the risks involved. Finally, the bleeding procedure plan. Write down a clear, step-by-step plan for how you and your partner would bleed the brakes on a car. Assign roles, such as who will be at the pedal and who will be at the wheel, and list all the tools and supplies you would need to do the job safely and correctly.